Okay, so just remember tomorrow's our test. And if it seems like we're pushing pretty fast, part of it is because it is, but it'll be helpful after midterm. Believe me, because um, just kind of keep that in mind. It'll be really helpful for us to get this chapter in before midterm, kind of thing, and then get those little two sections. Because then after midterm, it won't be nearly uh, grueling as if we didn't do that. All right, so tomorrow is our test. So in the morning, the 11 o'clock, we'll have further review again to go over anything you got. Let's see what we got on this problem. All right, so consider the statement. He orders a soup meal and he orders a salad or a soup meal. Use a truth table to determine which statement or statements written in English are equivalent to the original statement. All right, so equivalence, that's good. This is a good problem because that's what I was going to talk about with De Morgan's laws. And as I had said, is De Morgan's laws save you a lot of headache.
Sorry, just got back.
Hold on a second. Somebody's having trouble getting in. All right. All right. So De Morgan's laws are the same De Morgan's laws from chapter 2. And then I have them in here. They'll put them in a bunch of different places. But that's what we're doing with De Morgan's laws. The negation of the conjunction is equal to the disjunction of the individual negations of the two statements. And likewise for the second part, whether you're dealing with or and, all it does is just turn that sign around in the middle and then pass the negation on. All right. So that's what we're dealing with here. All right. So hold on a second. I'm going to try to import it so we can see it on the little board in there. There's something weird going on with Canvas, but at least we were able to get it. I was able to get into the Zoom. I was trying to get in and it was telling me it was overloaded.
Yeah, it did the same with me.
Because a student couldn't get in. All right, what is going on with this? All right, I'll just have to switch back and forth with it. That's all right. All right. All right. So so here's the problem we're working on. And then we're using De Morgan's laws to do that. Anytime you want to do an equivalent or a negation, you're doing De Morgan's laws. With the conditional, there is a special one, and then you use De Morgan's law to negate it. All right. So these are just the same ones repeated, right? So let's see if I can write it down correctly. I'm going to write it down here. He orders a soup meal and he orders a salad or soup meal. That's really just very similar to what we just did, but I can understand going through it again because we did that one pretty quick. He orders a soup meal.
Because soup is twice, that's
Can you read it out to me? Can you read it out to me, Tori? The original statement. He orders a soup meal, comma, is it?
I'm sorry, I was on mute. Okay. It says he orders a soup meal and he orders a salad or a soup meal. No commas.
Okay, so there's no commas.
No commas.
He orders a soup meal and he what?
Orders a salad or a soup meal. Period.
All right. He orders a soup meal and he orders a salad or a soup meal.
And then there's the 4.
Yeah. All right. So let's see if we can go ahead and put it in. So P would be orders a soup meal. Q. And that's the only other one. He orders a salad.
But then it says or a soup meal. So I'm like,
but it's the same statement. So now we're just going to write it as such. So it's going to be P and Q or soup again, right? So he orders a soup meal and he orders a salad or a soup meal.
okay.
All right, let me go back and look at it just real quick. So it says use a truth table. I was going to go with De Morgan's law, but let's just do it with a truth table since that one is, since truth table is the part that makes up the core of things. All right. So that's that one. So the other two would be he orders a soup meal and he orders a salad meal. So here's the choices. So then that's P and Q. Let's just call them something different. A. I'll come back and straighten up a minute. Make it longer. Oh, and that would be what? So this is he orders a salad meal or P. So this one would be he orders a salad meal. So Q is salad meal. And so then this is going to be he orders a soup meal. So that's P or P. So salad was Q. All right. All right. So finally got it written out. All right. So what we need to do is just create truth tables. So let's create truth tables. So was this in the review or it's in the regular homework? I mean, in the like individuals.
It's the logic equivalence. It's the
Yeah.
regular homework.
So thankfully we just got two.
Devil. I don't know if we can do that. I'm gonna ask him.
All right, let me see if I can did Chantel send me something? I mean, I can send that link and see if she can get in. Yeah, Justice got in with it. So I'll send it to her in a email because I don't know how else to do it.
Okay, I told her.
I ever had a issue with Canvas doing this in a long time. All right, if you could tell her to check your email, she can get that link I sent her. Yeah, well, that may help to have her sign in and come back out, but I thought maybe it was just Canvas is just acting weird. Even if it does work, it's slow. All right, so okay. Thanks, Tori. All right, so what? Let me ask you, Tori. What was this problem at in
So it was the
in
first,
the?
it was the first one under logical equivalence in the assignments. I watched the video. She did
Yeah, I wanted
a
to see something
table,
because
but
something's got me like worried about this one.
yeah. It's the first one that came up on it.
So logical equivalence. I just wanted to double check something on it. One of the, what I'm kind of concerned about here is just I had done one like this. That was actually that last thing that I did, and it had a, unless I'm missing something. And I don't know if they left out the commas or what. Because if you go back to question one in that, they have the commas. Because here's the thing is, and I would just be on the lookout for this one in the review. In the review, I'm going to go through and make sure that this doesn't appear on the test because I think something's wrong with it.
Yeah, I find
I was trying to see it
like this
because
but
there really should be a comma, and I'll just show you what I'm saying. All right. So that is what it should be in my head. So in other words, we're doing this. All right. Because if you don't have a comma, then it's ambiguous because and or they have the same precedence. They're not one's not dominant over the other. So let's just go ahead and do this one. Let's do that one first as that, and maybe that'll fix it. But I got a feeling that after I finish with this, I'm going to go and find, if it's in the test, I'm going to take it out. Because I don't, unless there's something that they haven't told us. Okay, so that's what we're doing. So I need to do the Q or P. So this is just basically the same old one. Doesn't matter that they're not in the same order because it's or. All right. And so then this part would be the both. All right, so I'm going to put together these two with the P and this one using and. So true, true, false, false. And the reason why, like I said, is we could just say, well, just fix it by putting the comma there. But if that's not what they intended, if they intended a comma to be over here, then it's going to be different. But let's see. I'll just go ahead and do it both ways. All right, so this one is just P and Q. So this one's not going to be it, but let's just say. So that's just the same old verbatim one. True, false, 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 because that's and. So there's only one that's got two trues in it. All the other ones have an F. All right, so this other one was Q or P, which is going to be just true, 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 false. All right. So I followed the same convention that I did for all of these. Just making the comma in this after the first one, after the Q, after the and or the or over here. So let's go ahead and see what we can do. So then we got to have, we got P and Q right there. The order doesn't matter, and we're going to put it together with P. So let's put it right here. All right, so we're doing this one and Q. So we're using and. So true and true is true. False and true is false. True. True and true is true. False. And false is false. Okay. So this was the first one. And then this is the second one. So make sure I got this right. Q and Q or P. So it's not this one. And it's not this one. And it's not that one. Because this is true, false, false, false. And this is true, 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 false. None of those match. So not that one. Not that one. And not this one. Now, let's do that last one. And then if I've guessed correctly about where the commas go, all right, so Q and P is right here. There's the Q and P, and then the P is over here. So we're doing the, I'll circle them in red. So we're doing P, and then this one. Oop, 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 nope. Q and P here. So P and Q and P, and then we're using the OR rule. So we're putting them together with the OR, the two in red. So true. True. This is a false one. And then this one's a false one. So this is the one that's the light.
Okay. So it's that one.
So that one is a light. So those two are equivalent. So it would be the D one. And like I said, yes, I don't like that problem. So if it shows up on the review, I'll even take it out of the review. Definitely take it out of the test because I don't, like I said, it should be a comma in there or some way for them to tell us that which two of those go together. Because you can use the precedence of the operators, but or and are they're on the same level. One doesn't take preference over the other. That's why you need to have a comma in the original statement. I think they just left it out, but I guess correctly where they were at. All right, so that's the procedure. And like I said, besides it being a kind of a crazy problem, it still works if I doctor it up a bit. So any
Yeah,
questions
the
about
issue I
this?
was having, it was just because of the ands and the
Yeah,
or.
like I said, yes, there should be a comma when you just got only ands and ors.
Yeah.
Like the biconditional is the most dominant. So whenever you have a more dominant one, it screams do this one first. So I'm sorry, do this one last. So the way you proceed is you go to negation and then you go to and or and then conditional and biconditional. But I can't use this here because and or. So do you have the little thing on yours that says feedback for that problem?
Yeah.
At the bottom, put that on there and click that.
Okay. Let's see feedback. And it says, wait, am I on mute?
Something's not right. Put on there, should there be a comma? Like,
Okay.
should there be a comma to differentiate between the and just be commas. Just say,
Okay.
we don't need to get too technical because they'll know what it is as somebody sees it. I'm surprised nobody's like said anything about this already. But this is a good one though for doing the equivalence because we could even use De Morgan's laws on this, but it's a little bit more complicated probably than the truth table. All right, think of something else. Let me check and see who's here. So so Chantel got in. It's like when I try to go in and put a record of who's in here, it doesn't just tell me something went wrong. All right, I'm just going to take a screenshot of who's here and then that way be done with it. See, and then the reason why this works and why you can also tell is see, they're in the same order like this one is in the same exact order as this.
Yeah.
It's just the only thing they've done is swap the and the or. They swapped the and the or on this one, but they also swapped the letters around. But if you just interchange the two symbols, the and the or, because they got that same precedence, then we know that one is going to match up. But when you change you can't do both. You can't change the letters and the symbols. All right, so anybody got anything else? I'll come up with some stuff for us to do. Let's see if we can go back to that textbook and look at some equivalences, because that's really the last major part. Besides the truth tables, then there's the equivalences and the negations. The equivalent and negations go together. This guy likes to show off his dogs. All right. Let's see if I can find us a good problem. Okay, so they start with a negation. Let's just do a couple of negations then, and then we do the equivalences, because the equivalences will come after this. All right, so here's with this one. Since there's only one or, there's not an or and two ors or an or and an and. So it doesn't really matter about this. So we don't have to worry about that precedent. So what this is going to be is, so P would be experimental seedlings. So P and Q would be diseased. So it's not Q. So that's the original statement. Okay. Right there. So P is the experimental seedlings are growing quickly. And Q is they are diseased, and then we negate it to give us that negation there. All right, so using De Morgan's law, okay, so we're going to pass, and I'm just going to show you. So the negation of that P and Q is what we're doing here, except that it's P or not Q. So remember, in order to negate that, we pass it through. So it goes to the individual statements, the P's and the Q's, and then it turns that sign upside down. The and turns to an or. So this or is going to turn to an and, like it does in the second one there. All right. So that means we're going to get this. Not P. The or becomes an and. Negation turns it upside down. The negation on the outside of that parentheses. And then it's negation of the negation of P. So we're going to take out that second negation, because the negation of a negation is just P. I'm sorry. Q, I'm sorry, that's what it should be. I put P. So then that means the negation of that statement is the experiment. Well, I'm just going to put seedlings. Are not growing quickly. And they are diseased. So that's the negation of the original statement. All right. So what can I help y'all understand that? Does that make sense, or is it murky?
Yeah, I mean, I basically just had problems with trying to write the symbols, the equation for the statements, like worded like that.
You mean doing
Like
this
whenever
part,
they
the last?
say, whenever it's like not, and I just,
Yeah, well, that's just part of the negation of something. Remember, if something's negated, if you take the negation of a negation, it turns it to being, the opposite. That's all you really need to think of it as. I know it's a little bit tedious. Let's see if we can look at another one. All right, so let's do this one here about the coffee is an espresso. Or, I mean, a latte or an espresso. So let me just be a little bit more formal. Let me go ahead and just define that PE is coffee is a latte. Q, coffee. So that's what those are standing for. And I'm just translating it to symbols because it makes the translation easier, or makes the negation a little bit easier than actually looking at the words, because if you look at the words, it can be confusing. All right. So that means that this one, number 40, is written as P or Q. And they're going to give us one that simple. Reason why I'm doing the simple one is because you asked about the negation. So let's just look at it like this. So the negation of that P or Q is not P. We're just passing it along to the P and the Q. But what the negation outside that parentheses does is it changes the or to an and. So therefore, the negation is the coffee is not a latte and it is not an espresso. So how about that one? Does that make a little bit more sense? Like I said, I don't mind going over another one because, like I said, this is the remainder of the stuff. We can even go over another truth table too. But basically, it can be broken down into. Yeah, well, it's a simple one. That's why I wanted to do it, because I thought maybe I had bitten off too much to explain there. But this is the simpler one, and that's just using De Morgan's law verbatim. But when you're negating something that's already negated, it turns it back to the positive form. But we can't just leave it in there because that negation is on the outside of the parentheses. So it has to pass along to both of them. And it passes along to the not Q. Well, not Q negated is just Q. And the or turns into an and. Same thing with this. The or turns to an and. The P gets negated. The Q gets negated. Let's try one more. I'm kind of surprised that they started out with the harder one first. Because now down here, this one is, this is the and. So let's look at the and one. All right, so P, I will go to college. Q, I will get a degree. Okay, so then this one is simply P and Q. So then the negation is going to be, again, we're just going back to De Morgan's law. And so when we negate that, we're negating the whole thing. So it just passes along. There's nothing to negate that's already negated. The and turns to an or, and then the Q is negated. So therefore, this is, I will not go to college, and I will not get a degree. That is the negation of the original statement. And like I said, yes, the Morgan's law is the key here. All right, so that's the negation. Let's see what they say about equivalences. Yeah, here's the equivalences. So it is not the case. It is not the case that my grade is an A or my grade is a B. Okay. It is not the case. Oh, okay. So what that is, I'll explain that to you, but that is not the case. So this is essentially A, P is my grade is an A, Q, my grade is a B. So then what this is this, not P or Q. That is not the case, means it's negating everything that comes after it. All right. Otherwise, it would have said my grade is not an A, or my grade is not a B, or they would have said, something different. But that is not the case, means the whole thing is being negated. So the equivalent is, by De Morgan's law, that's this one right here. See, we're passing the negation on to each one individually, and then we're turning the or to an and. So we didn't supply this negation because we're not negating it. Before, we supplied that negation by terms of negating it and still using De Morgan's law. But here, the not is part of it, and therefore it still fits into De Morgan's law. So then this is going to be not P and not Q. So then the statement would be, my grade is not an A and it is not a B. So that's the equivalent way of saying it. It's kind of akin to the old neither nor thing. So all right, let's try something else. All right, let's try this one here. All right, so we're going to take and we're going to translate, make an equivalent statement, and we're just using De Morgan's law. This one here is an and. It's an and. So this is the one we're looking for, the one with the and in it, and it's written like this side here. See, the prosecuting for this case is not experienced, and the prosecutor is not prepared. So this is the one we're doing. So we're going to write it in this form. But let's go ahead and just do the formalities of doing the individual P and Q, because that makes it easier to see. Okay, so I wrote them both in positive form. So then what that's going to be, that statement is not P and all right. So that's the way it's written now. Not experienced and not prepared. All right. So this is equivalent to or Q. So the way that those work is the equivalences when you've got the De Morgan's law. This is basically just De Morgan's law there written out like we have over here. So it's just kind of going backwards when it is going left to right rather than right to left. So this is the one we're going to write it as. So now I'm just going to write it out in words. So an equivalent way of putting it is not the case that the prosecutor is experienced and he is, we don't know if he's a he. Okay. So the not the case is the negation in front of the parentheses.
So is it supposed, it's and or it's or? Or does that matter?
Yeah, it matters. We're doing this side.
Oh, okay, okay. I thought we were doing the other
See,
side.
it's an and. Well,
Yeah.
I said it's backwards from the way that it's written in the Morgan's law here. But they're both equivalent no matter which one is on which side. All right, let's see what else we can get up to in this chapter or in this section. I want to do one with a conditional. Oh, that's an incident. So these are basically just you were defining the symbols and they want us to write them out. Let's do that real quick and then all right. So P is I need to talk to my friend. Q is I will send her a text message. Write the fault in symbols. If I need to talk to my friend, so if P, here's your if then I will send her a text message. If I do not send her a text message, if not Q, not P. All right, so like I said, there's one more thing I want to look at, if I can find it. I was hoping there was one in here about the negation of a conditional statement, because that still uses the Morgan laws, but we got to do one step before. All right, yeah, let's just talk about these again. These things, we looked at them a little bit yesterday about the basic statements, the basic conditional, and then writing the three forms. I was just looking for one other thing here, and I don't see it. A negation of a conditional statement. I don't see one. I'll maybe make one up before we head, but let's just do this. I don't let you copy these and paste them. So we'll do it over here. I'm going to do that 51. If we make a mistake on dosage, that patient may not survive. So that's the statement right there that we want to look at, and we want to write given the above, and this is the conditional statement, the converse, inverse, and contrapositive. All right, so I can put that away here now. All right. So this is what we're doing. Given the conditional statement, if P, then Q, then This is the conditional. So the converse is just turning them around. The inverse is just negating them in the same order. And then the contrapositive is essentially both. So I just take the converse and negate in that order. Okay. All right. So we're just going to use these. All right. So I need to define the P and the Q would help. The formal way is usually the most efficient way to go about it. Make a mistake on dosage. Patient survives. Put may. So I'm writing in positive form. So now, for the conditional, we already got it. That's what's given up there. So the converse is going to be, oh, wait a second. I just noticed something. It may not survive. So you need the negation there. All right. So then this is the negation. Well, I'll tell you what, let's do this a little bit differently. All right. So that's just general information about how it works. So our statement is, if P, then not Q. All right. If we make a mistake on a dosage, the patient may not survive. So the converse, we're going to need to do one of those negations of negations in a second on the inverse and the contrapositive. But right now, this one is just not Q, then P. All I'm doing is just turning them around. All right. So therefore, the converse is, if the patient may not survive, then we make a mistake on dosage. So there's the converse. The inverse is going to be now negating them in the order they got. So that's going to be P, not P, and not Q. Okay, we're just negating the two. We're negating this P here, and we're negating that not Q. So that means this is not P, Q. All right. So then the wording will be, if we do not make a mistake on dosage, the patient may survive. Oh, I'm sorry, I got it backwards. No, that's right. That's right. If we do not make a mistake on dosage, the patient may survive now. All right. See how I'm getting these? Let me know if you got questions, because we got enough time here. And this is probably the last thing I'll be able to do unless you got something else. And then the contrapositive is going to be taking the converse. So that's negation of Q, arrow, and then the P is negated. So then this is Q. If Q, then not P. So the contrapositive is if the patient survives, there's no then the all right, so there we go. Those are a pain in the neck, especially to go through from start to finish, where I said where you parse out and identify what P and Q is, because if you do it that way, it's easier to you're not biting off a big chunk, because if you bite off a big chunk, unless it's a real simple one, it'll be hard to do it. And this one was one where we had the negation. So any questions about that one? We probably got time to do one other thing. Let's see what I can find. I really wanted one to where I'll just make one up. I don't have one in here. It's the same kind of idea of what we're doing here. So I'm just going to do it now with a conditional statement. And the key to the conditional statement is this little rascal right here. So I'm going to write that over here on my little board. Okay. You know what? I was going to get rid of all this stuff here, so I'm going to have to put that back on there. Not P or Q. So this is just one of the other equivalents that they've got besides the to Morgan's law, and then the conditional statement and its contrapositive or equivalent. There we go. Let's just double check. Sure I got it right. P or Q, not P or Q. So I'm just going to make one up here. All right. So P classes are over. Q we attend. And I always write it in the positive. Now I'm going to write that statement as symbols only. P not Q. Now, I'm going to use that up there, that top thing, the first thing that I wrote, to write an equivalent one. Notice what happens. The P has to be negated. The antecedent has to be negated. So this is not P. And then the Q comes over as it is. And in our case, it's a not Q. So that right there, whoops, you know what? I didn't put the or. There we go. So you see how I've done that? I'm following this pattern here. This is an equivalence. We take this to the bank. So the P becomes a not P, the arrow becomes the or, and the Q comes over as it is. So on this one, the P gets negated, the arrow is an or, and then the Q comes over as it is. So I want to find the negation. That's what I'm going to do. Find the negate. Well, I'll tell you what. Find the equivalent and find okay. So this one right here is the equivalent statement. So the equivalent statement is classes are not over or we do not attend. That's an equivalent statement, believe it or not. It's hard to understand, but the reason why we do it is in order to negate a conditional statement, we got to put it in the form of a disjunction in order to use De Morgan's laws. So to find the negation of not P or not Q, use De Morgan. Captain De Morgan is what we need here, I think. My head is starting to hurt. So we're going to just negate it. So now it's going to negate each one separately. So the not P gets negated. It turns the or to an and then we negate that one. Well, what is that? Well, the negation of a negation, that just means P and Q. So this statement is classes are over and we attend. That's the negation. Whew. All right. I know y'all got to be tired. I'm just tired, worn out. So we'll go over some more in the morning thing in 020. So if you got that, try to go over that review and I'm going to go over it too and throw out some things for the test. But if you see anything you don't understand, bring it in, because I may do what I did with this one that you brought in, Tori. You know, it'll ease your mind a bit if we know we don't have to worry about certain things. Like I said, that one that you showed me is too complicated without knowing the where to put the comma at. All right, if you got questions, stick around. Otherwise, I'll see you tomorrow at 11.
Bye, thank you.
Okay, bye-bye.
Hi, are you trying to say something, Mr. Cruz, Professor Cruz?
No, I'm Justice. I don't think I'm going to do it on Honor Lock. I think I'm going to do the Zoom, but let me think about it. But yeah, you'll need the link. I'll what I probably want to. I mean, I'm hoping we won't have the same issue. But send me an email about that, and then I'll try to send it out. Make sure everybody's got it, because we had a couple people with the same issue.
Okay.
Okay.
And you say you was want to go over the review tomorrow with us?
Yeah, in the morning class. That's all review. Anything you got, bring your questions.
All right. Have a good day.
Okay.
Bye-bye.
I'll check out the system in the morning and see if everything is working. Like I said, this is the first time I've ever seen this. Anytime there's an issue, it's all right now. It looks like. Because I finally got in to the attendance. It wouldn't let me get in. All right, Alicia and Brandy, y'all hanging out? Y'all need anything? All right, let's see y'all tomorrow.